Hey everybody, today we will do another problem, and today we will do another signals and systems and with convolution type. Um, as we said last time, that this is the definition of the convolution. Usually it's like that. Some books express it like this. Like I said, this is not. Um, this is not. Different books. Some books have an H back here and X over here. So what I'm trying to say, it doesn't matter, right? It doesn't matter how. Matter of fact, some books have V instead of H. But this is the definition of the convolution. So in this case, we will do another problem. And it says right here in this book, like I said in this book, that it says to calculate, to compute the continuous signals of x of t and v of t in figure P2 29, and it says compute the convolution of the problem. Says compute the convolution of, the book uses this letter, B of t, x of t, compute the convolution of x of t convoluted with b of t, right? So in this case, we have the same, right? So we have the same, technically the same format as this, right? And the only thing on the definition, we change that to t minus tau d tau, right? And we know that tau is a dummy variable. So therefore, this definition, it just say that two functions, right, are two signals, right? We think in signals. We not, basically, generally speaking, it's signals, not necessarily the functions. But yeah, so this the one that we're going to do today is going to be, again, it's going to be a rectangular pulse, of x of t. So x of t, the height is 1, and it goes like this until 1, 2, and 3, and then goes down like that, right? So that is x of t, and of course, this right now is the time axis, right? And the other one is like this. It's a little height of height 2, and it goes like this, 2, and then it goes like this, but it's narrower. At time equal to 1. All right. So remember that the time, right? So basically, this is 2 signals in continuous time, right? And this is, the book called it B of t. I'm going to call it h of t. Like I said, it doesn't matter. Okay, so the question is, this can be interchanged like we said last time, right? Just because this is the format right now, it doesn't mean that it has to be like that. You can actually switch this and put the h over here and call it h of t, and then you can say x of h, and then you can say x of t minus tau. Okay, it doesn't matter. But in this case, we doing this, right? So this is the thing. So this is t. Now again, what is going to be our first step? Our first step is going to change. It's going to keep the same thing, right? So we do 1, 2, 3, and then we this go to 1 to 3 like that, and this is 3, right? But then we change this to tau. That's the first step, right? Change it to tau, and then this is going to be right now, because this is going to be x of tau. Right. So now right here, on this one we will do the same thing, right? So in this one we will do exactly the same thing with a height of 2. This is a height of 1, by the way. This is 1, right? And right here is 2, right? So this is 2, and we call that now h of tau. It's h of tau, right? So it's kind of keeping track with the taus and t's, and yeah. But this is tau now, right? So this is tau, right? Now that we have this, so we have the tau. Now that we have this, right, we changed the t's to tau. Now we will have to do the shifting and the flipping, right? The shifting and flipping. When flipping means multiplying, right, by a -1, right, which means flipping, right, to this side, right, and shifting means you add a t to it, right? So shifting, you add a negative, right? A negative, you add a 1 to it, right? Or whatever number, right? That number, it's relative too. So you don't have to kind of just, but then, like I said, you don't have to kick this like a certain set, a number. You can actually change these values and, and pick. You can pick right here, for example. You can actually pick. If you want to flip this, for example, you can actually flip this too. I am going to flip that one, right? But you can actually flip this one and find your region in this one. But then you have to say, okay, so that lands on 1, so that means that you have to subtract 1 from here, which means that it's going to be t minus 2, t minus tau, because you will, after you flip that over here, this overlapping is going to occur right here, so you have to flip that across, right? Even you can do 1/2 and flip that across, but then this is going to be 2.5 flip to the other side. I mean, you can do that too, no problem. Again, this is not like, this is generally speaking how to approach this problem. This is not a set of way to do it, like just one way will solve the problem. No, it's a couple different ways you can do this. Okay, so now this is this is the thing that you need to get in this. So you're trying to analyze two signals, right? And because this is like it's kind of mathematically, it's kind of abstract. You have to think about the changes, and eventually I will talk about the functions, the ramp and unit step functions and all that stuff. But right now, think about how two signals being convoluted will affect the system, right? So, okay, so now, so we have this, right? We have this signal and this signal. Now I change it to tau, right? Now, I'm going to flip this, right? And then I'm going to shift it, right? So if I flip h of tau, if I flip h of tau, right? So if I flip h of tau, it's going to be flipped, right? Like this. Right? So this right here, this is not the best. So right here, if I flip that, all right, so now this is h of minus tau. See? It flipped to this side. Now I'm going to shift it, right? So then I'm going to shift it, right? So now t is right here. Let's assume that t right now is shift, right? This is t, right? I'm going to add 1 to it, right? And add another t right here. So, okay, so now I'm going to shift it. So now this is going to be like this. Actually, it's going to be so let me do it right here. Right, so right here, you can see that I will have to have something like this, right? So now, right? So now I shift it, which means I will have a t minus, right? Let's assume that is 1, right? I shift it by 1 to the left. So that means I have to do 1, right? T minus 1. So t minus 1 and t, right? So t look like a tau because it's confusing. You're dealing with two different things, right? Okay, so t minus 1 and t length is in this corner right here. That's what it resides for now. It will be moving to the right, right? It will be moving to the right. When it moves to the right, I will be like sliding, right? So you sliding that to the left. I'm sorry, to the right. So it's like if I take this page, right? if I take this page and I am overlapping these two pages, right? So right now it's not overlap, and I'm going until I get over here, it's getting overlapped, right? Hopefully that makes sense. When we said overlapping, right? So we use the method of flipping and shifting to find the limit of integration where those two signals overlap. Okay, now, so with that being said, we can actually start doing the overlapping now, right? So we have, I'm going to overlap, I'm going to move this, right? So this is the same as this, and you know, right? So this is just shift, right? So now, when this right here, t is equal to 0, but I shift it to the other side, right? So now t is right here. I flipped it. When I flipped it, technically this is a -1, right? But the value of that, it was 1. Yes, it's 1. So yeah, it's 1 right there, right? So now, but I shift it, right? When I shift it, it becomes a -1, right? T minus 1, and t is this corner, right here, right? Now, so with that being said, now you will say, okay, what signal do I flip, or which one I flip and which one I shift? Well, whatever you pick. You cannot flip one and shift the other. Whatever you pick to flip, that's the same one that you will shift, right? Now, it doesn't matter. You can pick this one or this one. Sometimes signals are more complicated, so usually we pick the small one, right? Okay, so, but this is the thing. So now we have that, right? We have that. We have the one that we will be sliding forward, right? So when I do this, so if I have it like this, right? So let me just do this, right? So let me just do this, and this is the one that is 3, 1, 2, 1, 2, 3, right? Okay. Now, so notice that if I put this signal right here, right? So this region right here is 0, right? This is my shifted edge of tau, right? So this is my shifted edge of tau, right? And flipped it, right? Now, as you can see, this is edge of tau, right? It's a minus tau, right? Because I multiply by -1, but anyway. So right now, it's not sitting, not even close to where the region is, right? So at that point, right, you multiply this function with this function. Matter of fact, this is supposed to be a little lower. But this is 1, and the other one is, right? So maybe it's a little higher. Right. So this is 2. This is 1. I slide it forward, right? So now this is 0, right? Now this is 0. You multiply this to function, well, it's nothing over here. So this is 0. You slide it forward, right? Then you say that this is like this, and this is like this. So slide it forward. Right? It's still 0, isn't it? So this might be a little higher. So it's still 0, right? So this is the 0, right? This is the origin right now. At this point it's still 0, right? So notice that this is this guy right here, this guy which S of t. S of t, right? Now this is h of t, right? H of minus tau, right? So now, if it's nothing, right? It's not overlapping anything, right? Okay, so still 0. You multiply the signal, this is 2, and this is 1. This is still 0, right? But this is 1, this is 2, this is 3, right? So the height of this signal, or you can think about the amplitude of the signal. The amplitude is 1. 1. Now, if I do one more, right? Now notice that this is t minus 1, and this is t. T now is a 0, right? Well, the function value at that point is still 0. Why? Because we don't have any overlapping yet, right? Okay, the convoluted. Let me rephrase that. It's very easy to confuse people. The convoluted part is still 0. Why? Because there's nothing overlapping yet. The convoluted signal is still 0. Convoluted signal, right? It's not overlapping yet. Okay, so now let me move this to the origin and let me move this, not shift, but slide it to the right to 1. So now, in this case, it's going to be like this. So this is 1, 2, 3, and then this guy right here is going to go t minus 1 for the origin, and it's going to go to 1, right? So it's going to go 1, 2, and then it's going to be like that. Now the question is, do we have it overlapping, right? Do we have overlapping? And the question is, the answer is yes, right? Why? Because right here we have an overlapping. It doesn't matter this is higher than this. It doesn't really matter. Do we have an overlapping? Yes, we do. Right? So now that we have an overlapping over here, right? So this is t, but this is sitting at 0, right? Because this is sitting at 0, this is still technically 0, right? Now, what would be my limit of integration? Well, the limit of integration is going to this negative infinity. This negative infinity will become a 0 now, right? It's going to be 0. And then, what do we have? I just have a t, right? I have a t right there. So this doesn't count for the moment. This doesn't count for the moment. Eventually it will. At this point, just t, right? So I will integrate in t. Now, what is the value? Well, this is 2 and this is 1, right? So this one is going to be what? It's going to be 2. And it's going to be 2 what? 2 simply d tau, right? D tau. Okay, so having this integral like this, I can integrate this right now, and I can say that it's going to be equal to 2 tau, and the value is from 0 to t, right? To t. Okay, so, and I can call that y1. It's going to be the first one, right? Yeah, why not? I mean, you can say y of t1. So y of t1, right, is going to be equal to, evaluating that is going to be equal to t, right? I place t, and right here, of course, after I place that, I replace that tau, replace that 0, tau by 0 is going to be simply 2, and then 2 times 0, which is going to be just 2t. The first one, right? Okay, so that's the first one. The second one, we will shift this 2 more times. All right, so now I will, let me do it back here. So, okay, so let me just clear this up. Right, so at this point, we are going to make it, this guy, go up to here, right? So we go to this guy, this is 1, this is 2, and this is 3, right? So this is going to be t minus 1, and this is going to be t now. Now, this is going to be like that, right? And then it's going to be like that. And I'm going to drop the rectangle like that, right? The question is, right? Do we have any overlapping? This is t minus 1, this is t. Do we have any overlapping? And the answer is yes. We have an overlapping. And the overlapping region is right here. Right? So at this point, we have an overlapping, right? Now, the limit of integration is going to be between this guy and this guy now. It's not 0 no more. We just passed 0, right? So now, the new limit of integration is going to be, so the value is still 1, right? I'm sorry, 2. And the value of the function, right? So now, when I say the value of the function, I mean multiplying the two functions, right? So it's going to be, and we can call this y of t2, right? So now, instead of having 0, we will have t minus 1 to t, right? Now we have this area that we need to calculate, right? So, so, so then at this point, we will have, again, it's going to be the same thing. It's going to be 2. It's going to be 2 d tau, right? Which is going to be equal to 2 tau, right? And evaluate it at t minus 1 to t. Okay, so now we can do that again, right? So let me just put this, that the value y of t1 is equal to 2t, right? That's the first one. And let me just do this because I need a little more room. So, okay. So now, as you can see that you can see that evaluating that, right? It's going to be 2, right? T, right? Minus that evaluated at that is going to be 2, right? Is going to be t minus 1 again, right? When I do that, that is going to be 2t, and that's going 2t, and it's going to be minus 2t, right? And then it's going to be plus 2. Yes, plus 2. Just plus 2, not 2t. Plus 2. All right, so now if you look at this 2t cancel out, and I have just 2. So y of 2 of t is equal to 2, right? So we have those two values now. Okay, so now let's move this. Let's move this to the right again. So these problems can take a little longer, especially little complicated problems. So to show all this work, how you're doing this is going to take a little longer, right? Now this is 1, 2, right? Now let's put t minus 1 here, and let's put t here, right? So when I do that, this becomes like this, right? So it becomes like this, it becomes like that, right? So t now is a 3, right? Now the question you can ask is, can I go t past 3? Of course you can. But it doesn't benefit you any, because you knew already that at this point, when t was less than 0, there was no overlap. Well, the same thing is going to be over here. The highest point you can go at 3 in this case. 1, 2, 3, right? 1, 2, and 3. This is 0. That's the highest point. If you go past that, it's not going to benefit you any. I mean, because it's going to be 0 anyway at that point. There will not be overlapping here. Okay, so with that being said, let's do this. So we know that this is 1, right? This is 1 and 2. Let me just put t minus 1 here. This is 1. I'm sorry, this is 2 and this is 3, right? Let me just put it right here because I don't have a lot of room, so let me put 3, right? At this point, right? But this is what t will end up, right? And that is the value of t. So guess what? Right now, t is equal to 3. Then t will just disappear now. Why? Because t is 3. And that's the highest I can go. So the next limit of integration is going to be, okay, so the question is, where is the overlapping? Well, the overlapping now is here. Right? So overlapping here, right? So at this point, right, over here there's no overlapping, so we're not going to do that. But over here is going to be the interval is going to be from t minus 1 to 3, right? Why? Because this, in this case, this is the highest point. This is 3. This is 3, right? So this is 3, right? And then at this point, I'm going to put right here, t minus 1, and this is t. Right. Now let's integrate that. So now it's going to be 2 d tau again. Integrating that, I get 2 tau, right? Evaluated from t minus 1 to 3. Okay, so if that is the case, then just evaluate that integral, and we can call it that y3 of t. When we do that, we can say that this is going to be 2 times 3, right? Minus 2 times t minus 1. Minus 1, right? When I do the math on that, it's going to be 6, right? Minus 2t. Multiplying that times that, it is going to be a plus 2, which is going to be negative 2 plus negative 2t plus 8. Negative 2t plus 8. Okay, so y3 is negative 2t plus 8. All right, so in this case, right, so now let's plot that signal and see how that signal look like. But remember, we're dealing with signals here. So see, we have values, but also we have variables. So that means that it's a signal. So we have, okay, so you can analyze the signal, yeah. For example, you can call this that has some variable in there. You can call that like maybe some type of voltage that is variance, right? with time, right? You can call that a flat value, something it's a constant voltage. And what would be a constant voltage in definition, right? Well, a DC value. DC does not change, right? So when you have a number like that, a pure number, in electrical, you can consider this like a flat, like a flat slope, a slope that has no change on it. You can say that it's a DC value, right? You can analyze this in many different things. You can analyze that when the capacitor is fully charged, right? It's acting like an open source, something that is not changing, right? It's like right there, right? You can color this different so you can analyze this, right? The idea is over here. The idea is how the signals behave, right? In a computer, for example, when a computer is trying to calculate something, and you have like a square wave like this, that it goes like this, goes down, right? And comes over here, and then it goes up, right? And so what I'm trying to say is, let's say, for example, you have a signal like this, right? And you have a square wave like this, goes up to the same spot, goes up, goes across again, comes again. At this point, when it's making these changes, right, from 0, okay, so you got a 1 instead of 1, right? It keeps on 1 until it's at that point, the signal changes to goes down, right? And then it goes, let's say, for example, it goes all the way to 0. At that point it's 0, but at this point, in that instant, there might be a thing that's called a debouncing. And when that happens, that means that it's a time delay. So therefore, in the real world, nothing is perfect. So therefore, we have these changes, like you have 2, you have this variable there, you have that in, okay, so what I'm trying to say is, you can analyze the signals in a couple different ways. Okay, so, all right, so let's plot. Okay, so plotting this, if we need to plot this function, right, or I will say the convoluted signal, right, again, the convoluted signal, we will have something like this. And so we will have something like this. So notice that I have the first one is just a straight line with a positive slope, right? Right, something like that. And then the next one is 2, right? This one is 2, right? So, and remember that the height of that is 2, so it's right here, somewhere there, let's say that is 2, right? Now, from here, we go straight, right? And notice the value that I picked, right? I picked from 1 to 4, right? Why did I pick up 1 to 4, right? because um, because the type of value that I have for this y3, I will say the type of value that I will have, right? So let's say, for example, what make that equal to 0, right? So in this case, it's 4, right? But what we can do is the following. So we can do like this, right? So it's going to be a flat, like that. At 4, right? At 4, that function is 0. So a 4 is going to be 0. So in other words, that slope right there, that y-intercept becomes 0, right? And this is not the best drawing, but let me just kind of make this kind of needed. Right, so we have something like this. Right, we have a flat area. Right? And then this function will start decaying, right? But the thing is, at what point is that decaying? Well, the y-intercept, right? In this case, technically, so it's going like this, right? But we're looking for a value at what point that is 0, right? So we come like this, right? And then at that point, we say that decays, right? So it's coming like this, and then go like that, right? So at that point, so again, this is 2t, this is y1, this is y2, and then this is 2, and then this right here is y3, which is nothing but negative 2t plus 8, right? So that's how this will be the convoluted signal for this function. Thank you for watching, and if you like this video, just give me a like and subscribe. And remember that everything we do over here in this channel is because Jesus is good with us. Thank you for watching. Give me a like, subscribe to the channel. Thank you for watching.